Human Mars exploration, from takeoff to settlement. 1. Takeoff. The journey begins. Launch from Earth. A Mars-bound mission will likely use a powerful rocket, such as SpaceX's Starship, NASA's SLS Space Launch System, or Blue Origin's New Glenn. The spacecraft will be launched into Earth's orbit before making a precise home and transfer orbit to Mars, a journey that takes about 6 to 9 months depending on planetary alignment. Cruise phase, surviving deep space. Once in transit, astronauts will live in a confined spacecraft, protected by radiation shielding and artificial gravity if developed. They will rely on hydroponic food production, stored water, and CO scrubbers to recycle air. Arrival and Mars landing. Mars' thin atmosphere makes landing tricky. Spacecraft will use a combination of heat shields, parachutes, and retrorockets to land safely in a pre-selected area rich in resources, such as Valles Marineris for underground lava tubes or Gale Crater potential ice deposits. 2. Establishing a Martian base. Habitat setup. Once landed, the first priority is setting up shelters. Initial bases may use inflatable modules, underground lava tubes, or 3D printed habitats using Martian regolith soil. These will shield astronauts from radiation and dust storms. Water source. Mars has water ice deposits, especially at the poles and underground. Future explorers will use ice mining, extracting frozen water from underground. Atmospheric water extraction, pulling humidity from the thin Martian air. Chemical processing, breaking down hydrated minerals. Food and oxygen. Astronauts will grow crops in hydroponic or aeroponic farms using nutrient-rich water instead of soil. Genetically modified plants may enhance growth in low-gravity and CO-rich air. Oxygen will be generated via MOXIE Mars Oxygen in situ experiment, a system that extracts breathable oxygen from Martian CO. Power source. Since Mars gets 50% less sunlight than Earth, solar power will need advanced panels with energy storage. Mini-nuclear reactors, such as NASA's Kilopower, could provide a reliable long-term energy source. 3. Surviving and expanding the colony. Terraforming and construction. Once survival is secured, the goal is self-sufficiency. Martian regolith can be 3D printed into roads and structures, and underground habitats may be expanded to support a growing population. Communication with Earth. Signals between Mars and Earth take 5 to 20 minutes, so real-time communication is impossible. AI systems and autonomous robots will help with daily tasks and emergencies. Return missions and future expansion. With reusable rockets like Starship, missions may establish a permanent rotation of humans between Earth and Mars. Over decades, the first Martian city could form, leading to a self-sustaining civilization. The future, a new era of humanity. With water, oxygen, and food production secured, humanity can expand on Mars, turning the red planet into a second home. What was once science fiction is now becoming reality soon. Mars may not just be a destination, but a place to truly live. Would you want to be one of the first Martian settlers?
Thank you.